Ever catch yourself staring blankly at a tricky problem, wishing you had just a little extra brain power?
Like if you could just, I don't know, focus a little harder.
Yeah, exactly. Focus harder. Well, get this. Some researchers are exploring if LLMs could do the same thing.
Yeah.
Like, actually think harder at test time.
Really?
Yep, to get better answers. It's kind of wild.
That IS pretty wild. What are they doing giving these LLMs like brain teasers or something?
Uh-huh. Not quite. This deep dive is all about a paper, and it's called Scaling LLM Test Time Compute. Optimally can be more effective than scaling model parameters. It's looking at whether giving LLMs more time to think actually improves their performance.
Makes sense, I guess. More time to process, more time to consider different options, right?
Exactly. But it's not just about giving them more time, it's about how that extra time is used.
So how do they actually make an LLM think harder? Do they like overclock the processors or something?
Not quite that simple. There are a couple of core approaches they outline in the paper. Think of it like giving the LLM a chance to revise its initial answer.
Like a second draft.
Yeah, exactly. It's called improving the proposal distribution. They train these revision models that learn to iteratively refine their responses based on previous attempts.
Interesting. So it's like giving them a chance to learn from their mistakes and improve their answers.
Exactly. And then the other method is optimizing the verifier. Imagine having a super smart grader who doesn't just check the final answer, but actually evaluates each step in the LLM's thought process.
Oh, like a step-by-step breakdown. Makes sense.
Yeah.
So it's like a double-check system, ensuring the LLM stays on the right track.
Right. They call these process-based verifiers, or PRMs. And these PRMs can guide the LLM to explore different solutions, kind of like brainstorming different approaches to a problem.
So it's not just about thinking longer, but thinking smarter.
Exactly. And here's where it gets even more interesting. The research suggests that how effective these thinking harder methods are really depends on how difficult the problem is.
You mean for the LLM?
Yeah, like a simple addition problem versus writing a poem, they need different kinds of thinking harder.
So it's not a one-size-fits-all solution. You need to tailor the approach to the specific problem.
Exactly. That's
Yeah.
what they call compute optimal scaling.
Hmm.
It's all about giving the LLM just the right type of thinking it needs to succeed.
This is pretty mind-blowing stuff.
Right. And here's the picker. Sometimes a smaller LLM with the right kind of thinking harder boost can actually outperform a much larger, more complex model.
Wait, really?
Yep, it's a game changer. So all that focus on building bigger and bigger models might not be the only way forward.
So it's not just about size, it's about strategy.
Right. Now, I know you're probably wondering, how do these thinking harder methods actually work?
Yeah, I'm definitely curious about the specifics.
Well, let's dive into the nitty-gritty of revisions and verifiers in the next part of our deep dive. It's going to get even more fascinating.
I can't wait.
Okay, so last time we left off talking about revisions and these like super smart graders.
The verifiers.
Yeah, let's start with the revisions, like giving LLMs that second chance to get things right.
Like editing an email before you send it, making sure it's really what you want to say.
Exactly. So how do they train these revision models? Is it like showing them the right answer and saying, do better?
It's actually pretty clever. They show the model a sequence of wrong answers leading up to the correct one.
Oh, so like a trail of breadcrumbs.
Yeah. They call them revision trajectories. It's like showing the LLM how to step-by-step improve its initial guess.
Ah, I see. So it learns to recognize patterns in those errors and make better revisions. But couldn't it like overthink it and change a right answer to a wrong one?
That's where the verifiers come in. Remember, they act as a kind of quality control, making sure the revisions are actually improvements.
So it's like having an editor who catches those last-minute typos.
Mm.
I'm getting a clearer picture of how they work together. But what about different types of revisions? The paper mentioned sequential revisions and parallel sampling. What's the difference there?
Good catch. Sequential revisions are like, well, building a brick wall, you add one brick at a time, improving on the previous layer.
Makes sense.
But parallel sampling is more like exploring multiple paths at once. Imagine a bunch of LLMs all brainstorming solutions independently.
Oh, so you get a wider range of ideas, potentially leading to more creative solutions. But wouldn't that be computationally expensive?
It can be. That's why this idea of finding the compute optimal strategy is so important. Sometimes a simple sequential approach is best. Other times you need that mix of sequential and parallel to hit the sweet spot.
So tailoring the approach to the problem. No more one-size-fits-all, huh?
Exactly. It's all about finding the right tool for the job. And the research suggests that sometimes that might mean sticking with a smaller model.
As long as you can make it think harder in the right way.
Exactly. Now, we've talked a lot about revisions, ready to tackle the verifiers.
Let's do it. Those process-based verifiers, or PRMs, those sounded really cool.
Yeah.
How do they actually learn to evaluate each step of a solution?
Well, they use this technique called Monte Carlo rollouts. It's kind of like running simulations.
Simulations.
Yeah. Imagine you're at a fork in the road. The PRM simulates taking both paths and sees which one is more likely to lead to the right answer.
So it's like a choose-your-own-adventure for problem solving.
Exactly. And what's really neat is that this training is self-supervised.
Self-supervised, what does that mean?
It means the PRM learns directly from the problem itself without needing humans to label the data. It's pretty efficient.
That is pretty cool. But once you have this trained PRM, how do you actually use it? Like, how does it guide the LLM?
Think of it like a GPS for problem solving. We can use it to guide a search process.
A search process.
Yeah, we have techniques like beam search and look-ahead search that explore multiple solution paths and use the PRM's feedback to choose the best ones.
So the PRM acts as a guide, helping the LLM navigate through the maze of possibilities. I remember those search methods from the paper. Can you break those down a bit more?
Sure, imagine you're exploring a dark forest. Beam search is like having a flashlight that illuminates a few steps ahead on multiple paths.
Okay, got it. So you're not seeing the whole forest, just a limited view.
Exactly. And you pick the path that looks most promising based on what you can see.
So it helps the LLM focus its thinking on the most likely routes to the solution. And look-ahead search. That sounds more powerful.
It is. Think of it as having a much brighter flashlight that can see further into the forest.
Ah, so you get a better understanding of the potential paths and obstacles.
Right. It simulates more steps into the future, allowing for more strategic decision-making. But even with these advanced techniques, there are still limits.
Limits.
Yeah. The researchers found that for really challenging problems, the size of the model still matters.
So thinking harder can only get you so far.
Right. It can dramatically boost performance, but there are some problems where you just need the raw power of a large model.
It's like having a supercomputer versus a really smart calculator. Sometimes you need that extra horsepower. But even so, it's incredible how far we can push these LLMs with these new techniques.
I agree. It's exciting to see how we're moving beyond just bigger and bigger models towards more efficient and intelligent approaches to problem solving. Now, the big question that remains is, can these thinking harder methods eventually replace the need for massive models altogether?
That's the ultimate test, isn't it? Brains over brawn. I guess we'll have to wait for part 3 to find out. Okay, so the big showdown. Can these thinking harder LLMs actually take on the giants, the massive models?
Yeah, it's like David and Goliath, right? Brains versus brawn. Remember those researchers actually put it to the test? They took a smaller LLM and gave it all those thinking harder upgrades, then pitted it against a model 14 times its size.
14 times bigger. That's a huge difference.
It is. So what happened? Well, for easier problems, like basic math and fact-checking, the smaller LLM actually won.
No way. It actually beat the giant model.
Yep. Sometimes smarter is better than bigger, it seems. But it wasn't a total victory. When they threw really tough problems at it, like super complex reasoning or creative tasks, the big model still had the edge.
Wow, so there's still a limit.
There is. But even so, it's pretty amazing that a smaller LLM with the right kind of thinking harder can hold its own for so many tasks.
It means we don't always need to just keep building bigger and bigger models.
Exactly. This research is really changing how we think about AI. It's not just about brute force anymore. It's about using compute power in a smarter way.
Right, so like instead of building a monster truck to get groceries, maybe a fuel-efficient car that can plan the best route is a better choice.
That's a great analogy. And it makes AI more accessible too. If we can get great performance from smaller models, then we can use them in more places, like on phones or in areas with limited resources.
It democratizes AI in a way. Makes it available to everyone.
Precisely. And imagine, what if we could develop LLMs that could automatically assess how difficult a problem is and then adjust their thinking style to match it?
Wow, that'd be amazing. They'd become even more efficient and versatile problem solvers.
Right. Adaptable, like chameleons of the AI world.
Right.
And who knows what they'll be able to do in the future.
This whole deep dive has been pretty mind-blowing. Starting with how we can make LLMs think harder, and then seeing how it can actually change the whole game.
It really makes you think, doesn't it? And this is just the beginning. There's so much more to explore and discover.
It's an exciting time to be following AI, that's for sure. And a huge thanks to everyone for joining us on this incredible journey. We hope you found it as fascinating as we did. Keep those AI questions coming, and we'll see you on the next deep dive.